We begin this next section by talking about factoring. Directions are to write the prime power factorization of each. Okay. What we're really looking at is building a factor tree. So let's start by breaking down 72. Now we can use any multiplication fact we know that makes 72. I happen to like 9 times 8. The question then becomes, do you know any multiplication facts that make 9? And if you do, then we have to break it down further. Now we do know that 9 is 3 times 3. With 8, we know 8 is 4 times 2, so we are required to break it apart. So now we have 3, 3, 4, and 2. Do you know multiplication facts that make 3? There's just one. 3 times 1. And the times 1 fact we will not use. So you can't really break 3 down anymore. So 3 is locked. 3 is locked. 4, we know, is 2 times 2. But 2 is, well, 2. The only way to make it is 2 times 1. So that means 2 is locked. So when we break this all the way down, we get 3 times 3 times 2 times 2 times 2. So how do we represent this? The prime power. Prime power. Prime. Well, the prime numbers that make up 72 are 2s and 3s. We need 3 2s and 2 3s. Power. Exponents. If I have 3 2s in this factorization, that means that is 2 to the 3rd power. Prime power factorizations get to use x as a multiplication symbol. I told you way back in the beginning of the year, every now and then there would be things that allowed us to use the multiplication x again. This is one of those instances. The other item we have here are a pair of 3s. So we have 2 3s, that's 3 to the 2nd power. Prime power factorization. Break your number down as much as you can with multiplication facts, and then count up how many of each prime factor you have. The number 70. The most obvious fact to me that makes 70 is 7 times 10. And I don't see any reason to not use the most obvious thing. Now looking at these two numbers, 7 has no multiplication facts that make it. So 7 is locked. But 10, we all know that 10 is 2 times 5. Both of those are prime numbers, so they're locked. So what all do we have here? We have a 2, a 5, and a 7. One of each. What is the prime power factorization? 2 times 5 times 7. You will notice in my answer so far, and as I continue, you will continue to notice that my prime power lists are organized from least to greatest. So in number 1, I put my 2s, then my 3s. In number 2, I put my 2, then my 5, then my 7. Least to greatest. I do expect your answers to be put in this order as well. Number 3, we have 65. That's going to be 5 and 13. Both of which are prime. So the prime power factorization of 65 is just 5 times 13. Sometimes it will just be a multiplication statement. Nothing crazy. In number 4, we have the number 52. Now, I don't know a lot of facts that make 52 off the top of my head, but I do know that 52 is even, so I can divide it by 2. And half of 52 is 26. The 2 is locked, but 26 is even, And half of 26 is 13. 2 is a lock, 13 is a lock. So what do we have here? Two 2's, so that's 2 to the second power, times the single 13. The number 48 is 6 times 8. That's the first fact that jumps in my head. Both of these are even. They're not locked. 6 is 2 times 3. 8 is 4 times 2. In this row, the 2, the 3, and the other 2 are all locked. But the 4 can break apart into another pair of 2's. So what do we got here? I'm counting up 4 2's. So 2 to the 4th power times a single 3. Number 6, I have 74. I know it's even. So let's go 2, and half of 74 is going to be 37. Which is prime? Sometimes all you can do is divide by 2. In number 7, I see a number that ends in 0, so I'm going to take the easy route of saying, okay, 22 and 10. 22 is 2 times 11. 10 is 2 times 5. And all 4 of those numbers are prime. The prime power factorization, then, is 2 to the second power, because there are two 2's, times 5 times 11. In order, folks, in order. Finally, number 8, we have 394. So I know it's even. I can cut it in half. Half of 394, how are you supposed to know what that is? Well, what's half of 400? That's 200. This is 6 less than 400, and since we're dividing by 2, what is 3 less than 200? That would be 197. Oh, 197 certainly doesn't divide by 2. Does it divide by 3? Let's see, 1 plus 9 is 10. 10 plus 7 is 17. So if I add up the numbers that make 197, I get 17. And 17 does not divide by 3, so I know 197 won't divide by 3. So that knocks out 3. 5 won't work. 7 I don't think works. I am starting to suspect that 197 might be prime. Let me consult my friend Google just to confirm before I say yes it is. And 197 is in fact a prime number. So despite starting with something that looks like we're going to do a lot of work, 394 feels like we're going to be breaking it down for a long time, we actually immediately, when we divide by 2, have the final prime factorization. 2 times 197.